Most engineers assume that testing an MCP server means we need to connect to an agent like Claude or Cursor, then type a prompt and watch the tools getting called and performing the actions. This is basically considered as a demo and not a good test strategy because it is slow, it is non-deterministic, and every single run costs you the tokens. So in this video, let's discuss how to test our MCP servers without LLM in the loop. So by the end of this video, you will have a contract test suite for your MCP server that runs in milliseconds and returns the exact same results every time, that cost you nothing basically, and fits into the CI on every pull request. So no model in the loop at all. And if you watched my previous video on the 4 layers of MCP testing, this is the layer 2. So let me do a quick recap in case you missed that video. To put it simple, an MCP server exposes tools to AI agents, and testing it properly takes 4 different layers. So protocol conformance, tool contracts, security, and evals. So this video covers the tool contract layer. So here is the misconception. Since MCP servers are built for AI agents, most people assume that only an AI agent can test them. But think about how we test the RESTful APIs. We do not hire a human to click around in a browser and hope they hit our endpoints, right? We call the endpoints directly with known inputs and we assert on the response. An MCP server is also exactly the same. Underneath, it is just a JSON-RPC, and anything that speaks a protocol can be tested through that protocol directly without the AI on top of it. Now let's look into the pattern that makes this possible. The official SDK ships something called an in-memory transport. In the TypeScript SDK, it is just one line. In-memory transport dot create line pair. It gives you 2 ends of a pipe. You can connect a real MCP client on one end and a real MCP server on the other end, and both of them live inside the same process. There is no network call and no child process. It's just the real protocol messages flowing through memory itself. So here is the setup. It's just 4 lines. Create the linked pair, create your server, and then create a test client and connect both ends. So from here, your test runner does not care that this is an MCP. It is just an async function and a bunch of assertions. Any test runner like jest or vtest can run this test in local or in CI. Alright, so let's see what our contract test suite actually verify. So there are 5 checks. So the check 1, discovery. So here you will call the list tools and assert on what comes back. The specs says your tools list must not vary per connection, and every input schema must be a valid JSON schema. So let's snapshot the full tool definitions. This one is really handy because the moment somebody edits a tool description, the snapshot fails and the tests tell that something has changed. So let's review it. So if you remember in the previous video, I mentioned that the descriptions are the behavior. They are not just for the documentation purpose. Now let's look into the check 2. So the happy path. So here you will call each tool with valid arguments and assert on the results. And if your tool declares an output schema, validate the structured content against it. So this is what the spec also recommends, that the results must conform. Next, the check 3. So bad inputs. And this is where most engineers get it wrong. The spec splits errors into 2 kinds. Calling a tool that does not exist is a protocol error. So here you will get a JSON-RPC error back. But calling a real tool with missed or bad arguments or invalid arguments is a tool execution error. So this call will succeed and the result carries isError set to true. So with a message that a model can actually understand and act on. So your test should assert on both sides of that line because your consumers build their retry logic based on these messages. And the next is check 4, the error content. So when a tool fails, is a message actually useful? So let's say our message says like invalid departure date must be in the future. Then it helps a model self-correct. Instead, if you try to send a stack trace error, that will not be helpful. And you should also make sure that your errors never leak paths secrets, or internal details. And the next is check file, concurrent calls. So here you will fire several tool calls at once and make sure nothing falls over. So for each use case, like invalid inputs, valid inputs, missing arguments, concurrent operations, and so on. And this is one of the official recommendation that you will find in the inspector documentation. And if you're on Python, fast MCP gives you the same in-memory client pattern. So same idea, same speed. So give it a try. Now let's put everything together. So in a nutshell, this contract tester suite is deterministic. It runs in milliseconds and it costs you nothing, which means it can get every single pull request. So this is regression safety for the fastest moving interface in your stack. And let me be very clear about what this test does not cover. So it does not tell you whether a model can actually figure out how to use your tools. That is the evals layer testing. It does not discover the security issues. That is a layer 3 in my previous video. And it does not replace the protocol conformance, which has its own official tester suite. And in the last video, I promised a follow-up where we build the eval layer end to end, and I will cover that in a separate video. Alright, so here is what I would recommend you to do this week. Pick one MCP server that matters most to your team. And number 2, write the discovery test and snapshot every tool definition. That alone catches the silent contract drift. And number 3, add one happy path test per tool. And 4, add the bad input test, asserting the protocol errors and isError results separately. And number 5 is add one concurrency test. And for 6, you might need to mock your downstream services. So mock your downstream dependencies. So the only thing under test is your server's contract and not some third-party APIs. And number 7th is wire the suite into the CI on every pull request. So the lesson is very simple here. MCP servers speak a protocol, and the protocols are testable deterministically in milliseconds without a single token spent. So tell me in the comments, how is your team testing the MCP servers today? Are they using any specific agents, or they are testing through inspector, and are they building any test cases like this and plugging into CA server? Alright, so that's all for this video, and I will see you in the next.